Welcome to nCast, the podcast from nOps. Each week, we'll explore the world of cloud cost management, the latest in AWS optimization, and getting practical about your FinOps journey. Join us as we dive deep into the latest trends, tools, and best practices, while having conversations with leaders and luminaries who are innovating on the front lines. Our goal is to provide value to the community through insights and practical advice that will help you to achieve your FinOps goals. So whether you're in engineering, leadership, finance, or a cloud professional, this is the place for you. Sit back, relax, and get ready to join the conversation on nCast. Hi, and thanks for joining us today for this episode of nCast. I'm James Wilson. I lead up engineering over at nOps, and I'll be the host today. And I'm very excited about our guest today. Today, we're speaking with our principal cloud optimization architect, Andrew Lewis. Andrew is an expert in all things Kubernetes, and we're going to spend some time digging into that and geeking out on all things Kubernetes optimization. So Andrew, why don't you introduce yourself and tell us a little bit about how you became such an expert in Kubernetes?
Thanks, James. My name is Andrew Lewis. I've been doing cloud stuff for about 8 years. I think as part of that, I've worked at small startups that needed to pinch every penny, as well as larger organizations that wanted to, go on the FinOps journey. Way back in the way, Spot has always been a key to that journey. So I have kind of have some experience with Spot, but also understanding the RIs, as those came out of the market, as that came, savings plans that now come onto the market, and how to best balance all of them so that we, can save the most money in an organization. I'm excited to join nOps so I can bring that knowledge to as many organizations as possible.
Well, I could tell you we're excited too, and some of the things we're doing are just groundbreaking. We're excited to release them to the world. All right, so we're going to start with a little bit of history on container orchestration. I certainly remember the good old days building our first SaaS offering. We were talking about building images, AMIs, and we were using tools like Packer and Vagrant and Chef to actually configure AMIs manually, to build them, to configure them. Along comes Docker, this promising tool that had a totally different approach, and things kind of took off from there. Can you tell us a little bit about that progression?
Yeah, I think you can even go further back, and I have some experience going further back. You talk about, I used to work for the DoD, and we had to do gold images and build VMs for VMDK images that would be sysprepped and had all of those concepts. And ESXi was our layer that we used to optimize for that ability to deploy a known configuration.
Right.
And then you had Chef and Puppet come on the scene, and that was like really cool. So now I can deploy that thing and sort of manage it. Microsoft is like the granddaddy of them all. They had the, Active Directory. And then Docker comes along and it blows what I would say blows them all out of the water. All of a sudden you really had these immutable images that you would, in a way, to deploy them a lot faster than you had before and to ship them out there. So all of a sudden that was, there was some idea of container, or what I would say orchestration technologies at the time. If you think about it, like Mesos had this idea of running, you would basically deploy your jar files that had some ideas of keeping them stored centrally, or you could read them off of S3. But Docker was really, when that came on board, Mesos, for example, very quickly jumped on the Docker bandwagon. It's like, okay, now I have images that I can ship around. I can talk to a registry, all of those exciting things. And then everybody was like, cool. So we have Mesos and we have some other stuff. And you had Fleet by CoreOS. But then you had Docker Compose. Hey, I can start composing these different things. To deploy something onto a server. And you had people who were using Chef and Puppet to deploy Docker images on systems.
Correct. I'll admit it, Andrew. Nobody knew what they were doing.
Yes. And then the Docker Swarm, and then it was kind of like, okay, we need to build native Docker, things that understand Docker natively. And so you had Mesos kind of add some support for it, and then you had Docker Swarm. You added the other one, the new kid on the block was kind of an extension of Google's thing, Borg, and it kind of married some of those, a lot of the things that they had in Borg with a very strong Docker, like it only ran Docker. It didn't consider it, you could still theoretically run VMs on Mesos or do all kinds of hacky things. And it really started, basically eating everybody's lunch as far as a container orchestration platform. That was about the time I made my transition. As Kubernetes was blowing up, I wasn't in the 0 days, but it was, I remember 1.5, 1.6, 1.7, 1.8. I think 1.8 is about the time that I really got on board with it. And that would kind of just eventually won out. There has been some subsequent developments. You think of like Nomad's really interesting. Kind of, for my mind, Mesos has died, and I love Mesos.
I think I was at Mesos Con in 2015. I always think of those days as the container wars, right?
Yes.
We weren't sure. It wasn't obvious, and there was sort of team Kubernetes and there was team Mesos, and actually there was a big gap that Kubernetes had to make up. So, but Kubernetes had the support of Google, right? I think it came down to community support.
Yeah, you didn't have to read, but and I think that's still what Kubernetes is interesting. I mean, we shouldn't forget ECS. ECS was also about this time, and it kind of took some of those similar. It was Docker first, but probably with ECS is it was Amazon native and Amazon only. So
right, portability means something, right?
Right. Nowadays, with everybody on EKS, probably argue that maybe it's not as big a deal. Or with a lot of organizations running it that way. But at the time, that was like, that was a big headache. And then, where the community was that was where the tooling was. That was where, I didn't have to reinvent the wheel. It was all of a sudden I had real business problems that I didn't have to solve myself, like I had to do in other ecosystems, whether it was ECS or Mesos, that Kubernetes, somebody had already solved it. And there's a whole class of there's whole classes of problems, but there's a whole class of problems I could say, hey, I can just adopt something the community's built and I can plug it in and it works wonderfully. And that kind of continues to this day. When people say, oh, you should run ECS or run any of these others, I'm not against it. Usually I find teams get to a point, not all the time, but depending on how they grow and build, is that, oh, I see you re-implementing a lot of things that I either know there's a community, like you talk about other things like scaling or management of certain types of data, data layers like Kafka, that there's already a built-in solution and I don't have to reinvent the wheel. And I say this as somebody who ran Mongo and Mesos like a crazy person. And so the fact that there's an operators multiple for that I can pick and choose the best of, and I can also go off and run and do my own things, but there's a lot of table stakes problems even around the most basic things that I just don't do anymore. And that's kind of why I fell in love with Kubernetes.
Right. Centralized deployment.
Yeah.
And so I remember our first SaaS container orchestration environment. The great thing was that it was a shared environment, and there was huge advancements in horizontal scaling. We started to get away of thinking of everything in terms of vertical scaling. How much resources do I need to throw at this thing? And clustering became stateless. That was the sort of entry point to being able to move to that world. But in those days, we were running Kubernetes on VMs, and we were setting these clusters up ourselves, and still a little bit apprehensive about the EKSs and similar offerings in the world. So then we had to start thinking about scaling these clusters, right? Like there was no auto scaling, was there?
Yeah, it wasn't. And and that in Kubernetes, that was actually one of the things that was really attractive. Kubernetes had kind of a solution. It's kind of grown long in the teeth and it hasn't kept up with maybe what the community needs, but had cluster autoscaler. I found myself in, if we think about, I'm sure you do as well, but Mesos was really nice. It kind of came out of the same, I think, research community as Spark did. So it was really well fit into that scaling story. And that is what attracted to me in the first place. But it had no auto scaling. So I was doing a lot of things where I would be like, okay, I know we have a big Spark run. Okay, I can turn the button and provision 20 terabytes of RAM. And all of a sudden, that was exciting that my data science guys that I was working for loved it. But, they had to, page me if they were doing something after hours.
Right.
Started if we had, a client that we were rushing to get some data for. They're like, hey, buddy, can you turn on this or that? Or like, it's running slow. And like, well, I turned it down for the weekend. And, it was a very manual story. So Kubernetes was great because as long as you asked for the resources, it would, within limits, scale them up to meet it. And that was kind of a relative, new world for me as far as that went on. And I think a new world for everybody. And you could have built that in the Mesos ecosystem. You could have, built some of that scaling capabilities, but I didn't have to, and it wasn't critical to what my business was doing. So I didn't want to. I didn't want to have this bespoke software that I sat on and, did I get it right? All the time. So
now we're in a world, or at that point, we were in a world where, we were excited about the ability to sort of pull all of these resources, and people can allocate what they need to their project, but we're either implicitly over provisioned, or we're calling the DevOps team, on a Sunday afternoon to scale it up, because when they come in on Monday morning, they're going to be worried about revving the bill. And so we've got cluster autoscaler. How did EC2 Fleet, how did that play a role here?
So EC2 Fleet was really exciting when it came out, because all of a sudden I could ask for and get, and pardon me if I'm confusing, I think there was multiple versions of it, but the big revelation I remember was when I could ask for a diverse fleet of Spot. And that's kind of, that was really exciting to me, because we had data processing jobs that we didn't, we had checkpointing. We had to architect around it a little bit, but all of a sudden I could ask for 20 terabytes of, if a RAM constraint, I can ask for 20 terabytes of RAM for 90% off. And, we had to, this was such an ephemeral workflow that our guys were never going to fit. I'm sure I could have, there's people who have figured out the curve of like, if I get enough RIs, it'll absorb this level of these very spiky workloads, but still being able to instantly get 90% off. At that point, we didn't have, I didn't even know what the EDP was. We hadn't talked to Amazon besides getting our free startup credit. Right. So, it was trying to stretch those as much as possible. And the fact that I could issue a fleet request and, via some configuration habits come up on the other side was really exciting. That said, EC2 Fleet and Cluster Autoscaler were never really happy with each other. So as I transitioned to it, I kind of like made do with it. I would say, and we're going to do a little bit, but Carpenter was just an amazing new world for this, because I didn't have to deal with Cluster Autoscaler has a particular thing where it will look at a node in a node group, and then it'll determine based on that node on whether to scale. Well, if I have a really expressive Spot coverage request, so I request, all the way up to 12x or 18x or 24x or metal. I don't think that didn't really exist back then. But if I ask for these all the way down to 2x, as I say, my workload can fit itself on any of these things. There are some other constraints, like the amount of nodes you're running. But what would happen is it would pick one of those randomly, and it may pick one that has vastly different CPU than the rest of the Spot requests, basically. And so you ended up with very... you were spending a little bit more money, your scaling was imperfect, it would kind of figure itself out eventually, but, it was more annoying than it was worth at times. But you could still get 90% off, or you get 60% off, or, you were still getting that Spot pricing. So depending on the workload, it was worth it at times. Sometimes it was like, this is actually too much headache. So you kind of, where I was working prior to my last job and prior to getting in deploying Carpenter everywhere, we switched all of our development environments over Spot, and we saved a tremendous amount of money. I think we went from $1 million over budget to $1 million under budget after kind of doing some other optimizations as well as this. And part of that was buying RIs. Part of that was Spot. Same semantics didn't exist yet. But the other part of that was, switching all of our development environments over to Spot. It was just imperfect. It wasn't that Spot availability was bad. They had, Spot. Spot is a lot scarier to people. The big things that I often hear about Spot are, and I'm sure James, you hear this as well, is the conversations around, oh no, I've got a 2-minute warning, so my workloads can't handle that, and the fear of interruption.
There's the fear factor. It's always the fear factor with Spot, isn't it?
Yeah. And I would say that wasn't really what got me. Every once in a while, at that time, if we were narrow with our node choices, we would get crushed, basically. And the Spot termination handler was in the middle of that process. So once we got that even, instead of having no notice, we got some notice. But other than that, Spot could be finicky with the autoscaler. And so you would run into weird situations where you'd have to go in and lead a node or manually scale up a node group for a certain thing because it was calculating incorrectly. Clojure autoscaler has some, if you have EBS volumes, a little funky sometimes, so you could get some weird spots.
Even the messiest of workloads in those days and the messiest of scaling heuristics or algorithms, you could save money on Spot. That was the promise of it, right? You could be doing things totally wrong, but it's so cheap that it almost doesn't matter. The markets have changed, and the landscape has changed. Probably in those days, an organization that had 100 different AWS accounts would be an anomaly. Now it is common. We're managing things through organizations and CloudFormation stack sets. We're operating at scale, and the sort of matrix of complexity there explodes, right? Because you've got teams buying RIs, that centralized teams or teams they're making decisions on their RIs that they have absolutely no idea are impacting everyone in the organization. And that's why the landscape is difficult and it gets increasingly complex. But we're going to talk a lot about that. We're going to talk about it a lot in coming weeks because, at the end of the day, finding that perfect balance to be able to make the absolute most cost-effective decision at any given point is really where this game is headed. But let's dial it back for just a minute and talk about what are some of the challenges that are facing organizations in the today world, right? So we've got a variety of tools out there. Teams are measured in success by the number of nines that they deliver. What are some of the other challenges out there?
I think, we scratched at it, or we kind of hinted at it when we were talking about it before, but one of the most common things I hear when people talk about Spot, and I've been doing Spot for 8 years. Internally, organizations, one of the biggest fear factors I have is usually you have to get engineering buy-in, then you have to get engineering leadership buy-in, and they're usually very excited about the cost savings. And then you have to get business leadership buy-in, or depending on the organization, the shape of, how decisions are made. And the number one thing is it goes back to availability. I worked at a large clothing wear company. That was where I started using Kubernetes. And our biggest day, the day I was in charge of Black Friday. So the idea of any availability challenges scared us.
Heads will roll. Will roll. Right.
And at the time, we'd achieved cost savings through attacking development environments. It's funny though, if I go back in time, if I look at the tool landscape now, I would actually kind of go the other direction. I feel that people they better engineer their production environments so they can deal with Spot interruptions.
Right.
A little weird, like a weird backwards thing.
Even EC2 instances go away. Right. So I would hope that any modern organization is engineered for that. Right.
And they may be dealing with auto-scaling groups already. So the idea that they have a new node that comes online and comes offline, the 2 minutes. So one of the two things that I always hear people talk about Spot, the thing they figure out is they get a 2-minute warning, and the sub time that they get that. So, that's a at max warning. By the time your system processes it, maybe 2 seconds in, and maybe 15 seconds in, and maybe 30 seconds in.
Right.
And then the other thing is that there's a fear of interruption percentage, so that they'll be constantly interrupted.
Right.
There's a fear.
And there's a perception out there that this happens all the time, isn't there?
Yes. And I would say it, to be honest, I mean, the secret of spot is it doesn't. There is times of the year where you'll have some big guy come on and will rip and roll, especially through like GPU or maybe some of the CPU intensive stuff, and they'll just rip through the market. And then back in the old days when everybody would overbid. So you'd have this like weird situation where somebody, you could see like the max bid, I think at some point, and you were the max running rate that some of these spot markets would get to. And you would have this situation where it was like, if the instance, for easy sake, we'll say it was $1. Somebody had bid $5, but it was cheaper, still cheaper overall to keep that spot instance online, or the perception of it was. So they felt like they were still getting value even if they were running at $5 of 500x cost for some amount of time. So there's always this like, oh, it's really spiky, you can't anticipate the market, you don't know what's going to come off the line. Or even like when Amazon sends notices all the time that they're going to remove an instance, like, hey, we're going to remove an instance out of service. And you kind of, it becomes almost this like operational task to take those in. And, I've been in places where we literally had people who would like respond to those emails and like create JIRA tickets. And, we would schedule a reboot or something like that because, it was seen as risky of sorts. But at the same time, these were an auto-scaling groups, scale up and down. So it was just, I think there's mismatched expectations. You already have built these resilient systems. You're using probably, load balancers, whether it's ELBs or ALBs or NLBs. There are some constructs around that where you have to be careful. NLBs don't deregister that quickly. So you have to be careful about those sometimes. But generally, like these things the interruptions don't happen that much, and they don't disappear that often. And most of the fleet systems nowadays are designed there's a true run on the market, they're going to fall back to on-demand for you. And that's fine. Like I have used all of a resource in an Amazon region, but usually that's me doing something silly. Like I used all of the AMD instances in Tokyo one time because I wasn't paying attention when I rolled out a new Kubernetes cluster there. And I switched them all over to AMD. And apparently we were like the biggest user of instances in Amazon just because they were slowly bringing more capacity online. Not all of Amazon, but in that region per se. But the market doesn't move that quickly, and especially nowadays, like I think Amazon has maybe shaped the graph a little bit. I don't know if they would comment on that, but you'll definitely see more if you look at a graph of where the costs are. Maybe the market's just big enough now. You're going to see movement, but that movement is usually pretty, easy up and down. You're going to see the movement over the course of weeks, not hours, not typically.
Right.
In theory, somebody big enough, I'm sure I could try an example where I bid out all the spot on something in a region, and that would be a fun experiment, for somebody to try. If you guys had enough money to burn, could you bid out all the spot in a certain region and talk about the price? But stuff doesn't move that quickly in the spot markets.
Right. Well, which makes it suitable for all kinds of analysis, right? And I may be leading the witness here, but those trends and our friends over at OpenAI, the script kiddies with their Chat GPT will be having Chat GPT write ML code to analyze the spot markets, right?
And hopefully Amazon has. It goes back, I think it goes back to 2006 or something like that. They have the entire spot market. So if you did want to do that, you could dump the entire spot market. You could probably see the changes over time. And I mean, I'm sure, and I think about that, I'm sure maybe you could derive some investment value out of it because you could try to figure out who the big users. I don't know. That's probably the crazies. I worked in New York at one point, and that was always one of our like fun things, how you could derive some sort of investment market calculation, because so many of us had been exposed to fintech and kind of, some of the crazy research ideas they have. I don't know if it would work in this case, but and something, I don't know, this is way, way, way aside. But that you could totally, I mean, When I joined here, I had ChatGPT write a real script for me that showed me the cheapest spot instance in any region at a given time. I could have figured it out, but I could just ask ChatGPT to do it for me, and it took me 15 minutes.
Exactly. Yeah, I used it to write a Slack bot the other day just because why waste your time on low value code, right? Why waste it? And you'd be amazed how many engineers have it plugins in their IDEs right now because why parse JSON? That's no fun, right?
Yeah. Yeah.
But I digress. That's a whole other rabbit hole for another day. So let's, we're going to talk a lot about the landscape of RIs, savings plans, on demand, and spot, and some of the tools there's a number of tools out there. We've talked a lot about Carpenter. We love Carpenter. We're doing some exciting stuff with Carpenter. Stay tuned. We'll have the Carpenter team on here very soon to talk about some of those things. But let's get into just Kubernetes optimization basics. People are listening and they're going to be at a different point in their journey, right? And that's okay. That's okay. Engineers are, like I said, are measured in the number of nines that they deliver. It often feels like cost optimization is punitive. Nobody really has the time to figure out the complexity of the markets, the savings tools. And if you don't have sort of transparency in your organization or someone coordinating between all the teams in a very intelligent way, or using great tooling like NOps, right? That just crosses that problem off the list. Then the decisions that teams make have unintended consequences, or they don't have time to deal with it, or they're dealing with it only when there's a fire alarm. When the bill came in and it says, somebody over in finance says, what the heck, this is a 20% increase and we're not meeting our company goals. I've been in those stressful shoes. I don't know how many times in my career hit over the head with a stick. And so, that's why we're really not just adopting as an industry FinOps as a practice, but understanding that FinOps is sort of the same answer that DevOps was, 12 years ago about how to operationalize around what was availability, what became DevSecOps, so operationalize around security, how to operationalize around FinOps so that it's not a constant pain, it's not an afterthought, we're not driving in the rearview mirror. And that's really complex in a shared environment like Kubernetes. It's very easy. Well, maybe not as easy as you might think, but it's very easy to understand the cost of my EC2 computer or all of the EC2 computers in my autoscaling group. But Kubernetes delegating the resources, this is a pool. And so one of the biggest challenges is just understanding what am I spending where, right? What would you say teams can do to start to get a handle on just allocating what the heck that huge bill even accounts for?
Yeah. I've also been in those firefighting meetings. It's kind of in my experience. In my main job is to do the availability thing, and then every 3 to 9 months I get told that budget's out of whack. We got to reel it in, or we got to allocate it better. And that's one of the hardest things that I find FinOps teams struggling with is that they cost explore, and there's a multitude of apps, including ours, that do amazing things to figure out EC2 allocation and spend on these resources. And then Kubernetes provides us like cloak of invisibility, where they kind of have some idea what the EC2, they know what the penny, they know what the EC2 costs, but it's trying to figure out what it costs internally. And it's so vexing for some people that their immediate thought is, well, let's go back to, let's re-engineer everything again and let's go back, let's get out of Kubernetes. This is too hard. Let's go to Lambda because we can count every invocation. I've been in meetings where that we kind of had that conversation because that was how vexed we were at trying to save money. The number one thing, one of the easiest things. So I've used tools like Kubernetes, love them. It's not a simple tool. It's complicated. If you have a heavyweight,
Yeah.
you got to learn about Prometheus. You may be invested in Prometheus already, but you're gonna have to learn about Thanos. Or it supports some other backends, I think now, but it has to source stuff to S3. It's a somewhat complex install. It's trying to do a very hard thing. So you have to kind of determine what your appetite is. I think there's different, there's obviously, it's like in engineering anywhere, the 80% solution is 80% solution good enough? Can you start to use that to build heuristics? Can you start to use that to make actionable, insights? If you can, Kubernetes is trying to, the reason it's so complicated, and they again, I can't compliment those guys enough. They're really excellent in what they do. It's a very complex thing. As you get towards 100%, that gets exponentially harder. So, one of the laziest things I ever did is I made I had Prometheus installed. I made a Grafana dashboard. I knew how much CPU and RAM each instance type was using. I made up a fake number. It was a relatively fake number, but it was driven by, I knew what my instance families looked like. And I could kind of come up with a contrived number in a Grafana dashboard that I hard coded the multiplication with. Or you can do it in a spreadsheet.
You could do it in a tool like nOps. You could do it in a lot of tools, right? And I'm gonna agree with you there. I think the FinOps journey is about taking baby steps, right? You got to crawl before you walk, before you run, and if you follow that journey, you're gonna get cost allocation down to the penny, down to the pod, right?
Right.
And understand exactly how much you're spending, and until you have to go and overlay spot and savings plans and RIs on top of it. Don't blow your brain first. Try with a simple distribution strategy, right?
Right.
It's a tool where you can isolate your EC2 costs that by node group, by Kubernetes, or, EKS tags, whatever you can group those resources by, and do a simple distribution just to start to get a handle on this node group costs me X, this node group costs me Y, and you're going to allocate it to cost centers, because otherwise you don't even know how to start attacking the problem, and you don't have any sort of measuring stick to track yourself by month over month as you endeavor to try to get not reactive to cost, but signal driven, right?
Right. And, those sort of first baby steps kind of give you a shape of what you're going to be looking at. One of the things I would drive is there's be a long, if you're spending, $100,000 a month, it'd be a long tail of an app that ran 3 pods that was using in total 1.5 CPUs, and they could be using 1.25. And that's not really an interesting conversation, I think, for anybody to have. But you could, what I typically see is there'd be top 10, top 20 apps. They're the big, they're the mini monoliths of your ecosystem. If you have a microservice ecosystem, you probably do if you're running Kubernetes, or understanding, okay, what's my tax for running Kubernetes? I use the word tax, but what is the running cost of having all my monitoring tools on? When I flick on a machine, how can I allocate those sorts of expenses? Because I didn't get.
Yeah, tip to everybody who's listening, you can make the best node sizing choice, the most optimal choice, and unwittingly rev your monitoring bill, right? I remember one time thinking that we were making a great decision by downsizing and bin packing a little bit differently and going from a large to a medium. Hey, this is the most optimal thing to do. And then we realized we were running 3 times the instances or double the instances. All of a sudden, my monitoring bill doubled because they charge you by the host.
Or, in the real old days, you're running an etcd cluster. You're running small etcd master nodes, and you would blow them out because, I definitely did that at one point in a testing environment. I switched it over to T3s or something, and it's going to save us a bunch of money because it was unused. but we went up in instance size. I think it was like 300 to 400 nodes, and all of a sudden my etcd masters who were on smaller instances are chugging, and then it was an easy fix. I just had to resize my, and then you don't have to worry about there's any more, especially EKS and a lot of the GKE and the managed solutions. They magically do that for you in the background, and that's why we love them. But those sorts of unintended side effects are very real, and getting the shape of what you're spending and what your big things are, and that's really you can put that together in a lot of different tools. You can if you already have a lot of Prometheus and Grafana is pretty regular. If you have Datadog, you can kind of figure out your biggest, depending on your monitoring tool, you can probably from that figure out who your biggest CPU utilizers are. There's also usually a function.
Right.
Yeah. There's usually a function that shows you the mismatch to your requests. You can figure out a request and actual utilization. Sometimes that's an interesting thing to act on. Sometimes it's not, depending on what your workloads look like. But that was one of the first Grafana dashboards I built in my last two companies, was show me the difference between utilization and actual request rate. And you would kind of look for the ones that were big or misconfigured. And you would run into, hilarious stuff like misconfigured HPAs. We're talking about VPAs and HPAs, those.
Let's get there. I mean, so let's talk about pod sizing, right? Right. So, it's my experience that most pods, or many teams, and I don't want to throw teams under the bus here, but many teams don't even have their requests and limits set on their pods. Introduce newer tooling sets, and we might be asking ourselves, why even bother, right? So what's step one? What's step one?
This is another digression, but that was one of my biggest things that messed going from Mesos to Kubernetes, is that Mesos, you very explicitly define a task. You had to assign it something.
Had to do it, right?
Right. And Kubernetes, it will do a default, I think. It will do a default. But it's like 100M. Depends on, I think you can tune this. I know you can tune this, let me put it that way. But by default, it's 100M CPU limit. I think it does no RAM request. So yeah, that's a huge, you have, basically people have tuned an auto-scaling group to match whatever the usage is, and it's exclusive to this thing, so only this thing can run on it. And that's one of the, we've mentioned Carpenter, but that's one of the biggest, you have to go back and fix that when you switch over to a tool like Carpenter, because it can't, or even Cluster Autoscaler would have problems with this, about what it would require, unless you very precisely limited what could run where. If you just put a workload and said Cluster Autoscaler had no idea about the node, the node labels it needed to consider, or the node group it needed to consider, it could do all kinds of wonky things. If you weren't expecting, why is my one, version of app way slower than another another pod of the same app? So, that it's a get good requests, whatever you think good requests look like on your, because that also feature metrics, get good requests.
It's going to put a framework in place, right?
Right.
And, I think that, we're running short on time. This conversation is going to go on and on and on. And I'll spoil it for the audience. We're going to get into advanced tooling. We're going to get into RI automation. We're going to get into spot automation. We're going to get into variable workloads, but and we're going to get into how to do it easy. But I think that the short story is that there is value for any team in doing the basic cost allocation, the basic setting of requests and limits, so that you
reviewing.
And you'll never be able to review them forever, right? But review where they're at today. That's step one. But before you even can act, you can't quantify the problem. You may not even know what the problem is until you go through the exercise, and there's going to be a huge amount of value in it.
And if you want to automate that, you can you can do some automation around VPA to try to get some numbers out. I would review those numbers that you get from VPA. VPA can make decisions that lead to pods not starting up because they're too, depending on how the life cycle of the pod exists, they may be too small for what VPA can see. But if you want to collect some numbers, there's ways to use. One of my favorite things, what I did at my last job, Converno, is a really powerful mutation engine and enforcement engine. But one of the things it's really easy to do was, as soon as you see a new deployment pop up or an existing deployment, create a VPA configuration that's in watching mode, basically.
Right.
And that will spit out some numbers at you. There's also
there's your tip of the day.
Yeah,
that's a great hack.
Yep. Fairwinds, which is Kubernetes. I think they do Kubernetes support, but they have another tool. They have a tool that does this for you. I found it's just easier to do it with the Converno side, but their tool is fine. I mean, we just had Converno in place that was easier for us to install than installing yet another tool that only does this very specific one thing. So Converno it's really powerful at doing a lot of. I've used it for cost savings in all kinds of fun ways. But that's a really powerful, simple idea. Is, build automatic VPA recommendations, review them, and then apply them or you don't have to apply the VPA, but apply the recommend.
Right. Apply the recommendation. Right. Apply the recommendation. Right. Well, I'm excited to see where this conversation is going to go. I don't know if people are following us out there, but if you were nerdy enough to follow that conversation, then that's just the start, folks, because we're going to talk about some really deep topics and what we're doing and the people that we're working with and sort of the leaders and luminaries who are out there in the field, in the mines, doing the work. And innovating in these areas. So, Andrew, let's cut it off for today. It's been a pleasure talking to you, and we're going to talk a lot more on these topics. Thank you so much.
Yeah, thank you. It's been it's I always love to geek about these things. So this is a great waste of my time. It's not a waste, but a great usage of my time because I love geeking out about all this stuff. And,
right.
Even talking about the history of stuff, it's like, oh man, do you remember when this thing was this way? And there's a lot of I think people are like, oh, it's new technology, it's the new thing. It's like it's the same sort of ideas. We try. I think people will have the same sort of ideas over and over. I mean, people say that too, but same sort of ideas. And there's always some new thing, and the cloud has added a huge component of cost, but people have been having to deal with costs of data centers, way back, it's the beginning of data centers.
It's just changed the problem statement, but the problems are still the same, or the way they manifest themselves are differently.
Yeah.
All right. So we're going to get into Carpenter. We're going to get into auto scaling. We're going to get into bin packing. We're going to get into cost allocation and shellbacks. We're going to do all of those things. So I hope that everybody's out there listening is going to tune in for the next episode. We've got some exciting guests coming in. For today, I'm James Wilson. I've been joined by Andrew Lewis, and we want to thank you for joining us and hope that you tune in next time. Thanks for tuning in to nCast. We hope you enjoyed the episode. As you can tell, we love to geek out on all things cloud optimization. If you have any questions or feedback, we'd love to hear from you. You can find us on LinkedIn, Twitter, or Instagram, or just shoot us an email at ncast@nops.io. If you'd like to learn more about the continuing innovation over at nOps or about our free FinOps platform where you never pay anything unless you save money, check us out over at www.nops.io.